Hi everyone, this is the homework write-up for assignment number 36 on pages 50 through 53. Pages 50 through 53. Alright, let's see if we can address some of these issues. 87 is our first problem. 87 says, write the area of the square as a function of perimeter. Area of the square as a function of perimeter. Okay, so what do we know about area of a square as a function of perimeter? Well, I know a formula for area of a square. It's side squared. But this problem says we want as a function of perimeter. We want only P stuff over here. No S stuff. So I have to find a way to get rid of the S and introduce some P stuff. Well, do we know a relationship that we can use for a helping equation? A way to connect the S we have that we don't want with the P that we do want? Well, what is perimeter? In this picture, perimeter would be all the way around added up 4S. So what we said in class was we're going to solve the helping equation for the variable we want to get rid of. What variable do we want to get rid of? We want to get rid of S. What variable do we want to have? We want to have P in our answer. So I have to take this equation, P equals 4S, and I have to solve it for the variable I want to get rid of. I want to get rid of the S so I can have area as a function of perimeter, not area as a function of side length. So I'm going to divide both sides by 4. And I'm going to get S is P over 4. So where I see S up here, I can replace that S with P over 4. So now area is going to be P over 4 squared, or P squared over 16. There's my answer to 87. Okay, let's take a look at 88. That's the next problem we've got. 88 says, write the area of a circle as a function of circumference. Area of a circle as a function of circumference. Okay, well, what do you know about area of a circle? Most people are comfortable with area equals pi r squared. Here, our area is a function of radius. See the radius stuff over here? Well, I'm supposed to have a function of circumference. So I need to get rid of that r and replace it with some circumference stuff. Do we have a helping equation? Well, we're supposed to know from middle school and from geometry that circumference equals 2 pi r. Again, this is my helping equation, so I'm going to solve my helping equation for the variable I want to get rid of. I want to get rid of radius because I'm asked to write area in terms of circumference. I have to get rid of radius and get some C stuff over there instead. So if I solve my helping equation for radius, I can replace radius with this C stuff. So we'll have pi C over 2 pi squared. Now, like we learned in the Algebra Basics unit, we're going to apply this exponent to each of these objects. C squared, 2 squared is 4, pi squared. I notice on the diagonal that I've got a pi up here and a pi squared here. So I can cancel a pi out. So I get C squared over 4 pi. That's area as a function of circumference. See, no more radius here. We replaced radius with some stuff in terms of C. But that meant that we had to know circumference was equal to 2 pi r. These problems are really hard to do if I don't remember my basic math facts. Okay, next question. We've got 89C. 89C. We're asked to write the volume of the box, write the volume as a function of x and determine its domain. Okay, so in this situation, in problem 89, they show us using a square piece of material, 24 inches on a side, and we're going to cut out these corners like I did in class and fold along the dotted lines. We know that each of these is x by x, and we know that the whole side is 24 inches in each direction. When we fold up these flaps, it's going to make an open-topped box. So, what are the dimensions of this open-topped box? In 89C, we're asked to find the volume of this box. And we know volume is length times width times height. And if we don't know that, we really need to. Okay, so I've been asked in 89C to find volume as a function of x. So somehow I need to write these in terms of x's. Well, let's go back up here to our picture. This here is this here. So how long is this? This is our length. How long is this? Well, in this picture, I see that this distance is 24, and this distance is x, and this distance is x. So if I remove those x's from my 24, I'll get this piece. So 24 minus 2x. Okay? What about this length, which we can call the width of our box? Well, that corresponds to this over here. Notice this is 24, this is x, this is x. If we take these x's away from this 24, we'll have our width of our box. So that'll be 24, again, minus 2 x's. All right, well, what about the height of the box? Well, that height is formed when these flaps come up and meet each other along this line. And these flaps are x units long. So it looks here like the length is 24 minus 2x. The width is 24 minus 2x. And the height is x. If I think about the graph of this function, it has an x-intercept at 12 and an x-intercept at 0. How did I know that? Well, if I'm looking for the zeros of the function, or an x-intercept, I set that function equal to 0, and then set each of the factors equal to 0. And so I get x equals 12 here, and x equals 0 here. So what does my graph look like? My graph looks like this. Now, why am I graphing this? Because the second part of 89C, the first part was to write this equation. What's the volume as a function of x? The second part asked me what's the domain of this function. Now, to me, this looks like a third-degree polynomial, and we said before that for third-degree polynomials, you could plug in any number, so the domain should be negative infinity to infinity. However, this third-degree polynomial takes place in the real world. It represents the volume of a box. See all these output values here? Those are volumes. Can I have a negative volume? No. So I need to throw those away. No negative volume, and no negative x's. Can't have a negative x. My height can't be a negative number. Okay, I'd like to further consider over here. What happens if x equals 14? Well, 14 here is fine, but what happens when I plug a 14 in here? 2 times 14 is 28. 24 minus 28? That's negative 4. Can this side length be negative 4 and this side length be negative 4? Because that's what's going to happen over here. 24 minus 28. I'm going to get negative 4 again. So even though a negative times a positive would make a positive volume, I can't have negative side lengths. So 14 is going to make a negative side length. Anything bigger than 12 is going to make a negative side length. 2 times 12 is 24. 24 minus 24 is 0. That's as far as I can go. So I say my domain, when I throw this away, because that makes negative side lengths, and when I throw this away, because I get negative volumes, my domain is just going to be 0 to 12. Okie doke. Next, 92. Let's take a look at 92. 92 says a rectangle bounded by the x-axis and the semicircle y equals square root of 36 minus x squared, and they even drew a picture of this for us. Write area of the rectangle as a function of x. Okay, so let's start off with this picture. We have a semicircle. They tell us that this is 6, and that this is negative 6, and that this is 6. Okay, and they say, write the area of the rectangle as a function of x. Well, I remember that area of a rectangle is length times width. And if I look at this rectangle here, I see that the rectangle has a length and that the rectangle has a width. All right, now this problem is not about guessing numbers for these things. It is instead about this little ordered pair labeled in the picture here called x, y. Why is that important? Well, what's the amount of upness to that ordered pair? That upness is our y value. What's the amount of overness to our ordered pair? That overness is called x. I know that a semicircle centered on the origin is an even function with y-axis symmetry, so I know this distance over here is also going to be x. From this picture, I can see that the length is x plus x, or 2x, and the width, this amount here, is y. So now I say, well, is area a function of x? Well, not quite. Area is a function of x's and y's. So I really need a helping equation to get rid of this y and replace y with some x stuff. Do I have that? Well, I notice here in the picture it says y equals square root 36 minus x squared, and it points to here. So what's y equal to? This x stuff. So I can turn area into a function of x by replacing this y with what y is equal to. 36 minus x squared. There's my area function for number 92. It says here, determine the domain of the function. Well, I'd be okay if you said that the domain went from negative 6 to 6. I'd be okay with that. I wouldn't enjoy that. I think a better answer is that the domain goes from 0 to 6, because my x values can't be negative numbers. So either of these would be fine on a test or quiz that we see. All right, well, that's all we had to do, come up with area as a function of x and talk about its domain. Why negative 6 to 6? Negative 6 to 6, that's the domain of this semicircle. Why 0 to 6? Because no negative x values allowed. So I went from 0 to 6. All right, there's 92. Let's take a look at 93. 93 is a thrown baseball. Okay, we've got y equals negative 1/10 x squared plus 3x plus 6. And we're told that this is y and this is x, and we know we've got a downturned parabola here with a y-intercept of 6. Okay, this x represents the horizontal distance. How far away from you horizontally is the baseball? These values represent the height of the ball. Now in our problem, we're told that will the ball fly over the head of a child 30 feet away trying to catch the ball? So on my graph, I don't know where 30 is. Is 30 here? In which case, maybe that ball goes over the head of the 5-foot tall child. Or maybe 30 is over here, in which case they're going to have to walk over here to pick it up off the ground. But maybe 30 is here, where the 5-foot child and the would just be able to catch that. So I'm going to have to think about this. Okay. I've got a down pointing parabola. They want to know, will the child who's 5 feet tall be able to catch this ball when the ball is 30 feet away? If the ball is 30 feet away, we know that x equals 30. So let's plug 30 in for these x's and see what we get. Y equals negative 1/10 30 squared plus 3 times 30 plus 6. Well, I get 6. That means when the ball is 30 feet away, it is 6 feet in the air. So I think we've got this situation where we're 6 feet high at 30. Well, the child is 5 feet high. They ask us, will the child be able to catch the ball? Well, I think if they put their arm over their head, their arm is probably more than 1 foot long, they'll be able to catch it. But maybe not, because it's not at 5 feet. So I'll let you choose whether you think the child will be able to catch that ball at 6 feet high, even though they're 5 feet or not. Okay? But I do know that when the ball is 30 feet away, the ball is going to be 6 feet in the air. Okay? So that's all we had to do for 93. Let's see what the next problem is. Next problem is 95. 96. 96. Ooh, the post office. The post office says that the combined length and girth is 108 inches. Okay, so I've got 108 inches for girth plus length. Well, let's see if we can figure out some equations here. We know this is x and x and x and x, and we know that this is y. Well, it tells us in the problem that girth is the perimeter of the cross section, which means this plus this plus this plus this. So girth is 4x. And here I'm told that girth plus length would equal 108. So I've got 108 equals 4x's plus a y. 108 is the combined girth and length. Okay, what else? Flip the page over. It says in part A, write the volume V of the package as a function of x. Well, I know volume of a box is length times width times height. So this times this times this. So volume is x squared y. Is volume all in terms of the variable x right now? No, look, there's a y there. I have to figure out a way to get rid of that y and replace that y with some x stuff so that I can have only x's on the right side of the equation. All right, so what will that look like? Well, thankfully, we have this helping equation over here. If I subtract 4x from both sides, I can solve this equation for the variable I want to get rid of. Remember what we said earlier, we want to solve the helping equation for the variable we want to get rid of. I want to get rid of this y and replace it with some x stuff. When I solve this equation for y, I get 108 minus 4x. So then x squared 108 minus 4x. Okay, so that's volume as a function of x. That's part A. Part B, use the graphing utility of your function to graph the window, set an appropriate viewing window. Well, I have x-intercepts at 0, and I have x-intercepts when I set 108 minus 4x equal to 0, or 108 equal to 4x, I get x equals 27. So this is 27, okay? So now my graph looks like this. Again, this is volume, and this is x. Part B says graph it. So I've graphed it. Now, it says use an appropriate viewing window. You know, this is a cubing function, right? X squared times x. We're going to have negative 4x to the third plus 108x squared. This is a cubing function. That means I take numbers like 27 and plunk them in there and cube them and then multiply them by negative 4. We're going to have some big numbers here. If I take 30, which is nearby, and cube it, but much easier to work with than 27, 30 times 30 times 30 is 3 times 3 times 3, stick on 3 more zeros. So that's 27,000. So I'm going to set my y max at 27,000. And I'm going to set my y scale at 1,000. Okay? Let's see if we can see this on our graphing calculators. I'll pull mine out of my bag. We'll graph this function. Here it is, x squared minus x squared times 108 minus 4x. And if I change my viewing window so that I go from 0 to 27,000 in steps of 1,000, I see this. Well, that's this part of the graph. Why don't I care about over here in negative x land? Can I have a negative side length to my box? No, so I throw all of that away. Can I have a negative volume for my box? Because any numbers below this x-axis, those are volumes, and so volumes are going to be negative here. I can't have a negative volume for my box. So my domain really only goes from 0 to 27, and that's why I set my x min to 0 and my x max to 27. So there's my graph. And then what does it say? What are the dimensions that will maximize the volume of the package? Well, this is V, and I see volume is maximized about here. I can do second, calculate, maximum to find the location of that maximum. I'm sure glad we did a graphing calculator lab on assignment 7 so you can all be comfortable with using your graphing calculator. Now, see that 0.00002? That's going to be rounding error on your calculator. Really, the value is exactly 18, and if we use our calculus next year, we'll be able to determine that the exact value for x is 18. Please note, even though it says y here is 11,664, this is not 11,664. This y is about this axis, and remember, that's volume. What we know here is the maximum volume is 11,664 when x equals 18. Okay, so they wanted to know dimensions. we know x equals 18. But our dimensions are length times width times height. I know these are 18. But what's this? How long is that? How can I find how long y is if I know that x is 18? Well, conveniently, you've already done that. See here? Your helping equation will help you some more. It's already solved for y equals exactly the thing that you need to figure out to say what the dimensions of the maximum volume box will be. So you just have to plug that x equal to 18 in here. So what do we get when we do that? Well, 108 minus 4 times 18 is 108 minus 72, or 28 and 8 is 36. So we know that y needs to be 36. The maximum volume occurs when x equals 18 and y equals 36. So the dimensions of this box are 18 inches by 18 inches by 36 inches. Those are the dimensions of the box with the maximum volume. Okay, that was 96. Let's take a look at 98. 98 says average cost. We're told in this problem that the variable cost is 95 cents for producing each game. So 95 cents per game. And we're told the startup or fixed or initial costs were 6,000. Well, I remember back on assignment 2 when we said, hey, if I'm trying to build a linear model, I know that total equals starting amount plus rate of change times the input variable. Well, here's my starting amount, here's my rate of change, and my input variable, they said, should be x. So I think cost as a function of x is 0.95x plus 6,000. That's my answer to part A. Write the total cost as a function of the number of games sold. What about part B? Part B says, write the average cost per unit, C bar. And they then go on to tell us that C bar equals C over X. Well, we just found C in part A. So 0.95x plus 6,000 over X. And there's my average cost as a function only of X stuff, right? This isn't a function of X stuff, it's a function of C and X. I need to get average cost, that's what C bar means. C bar means cost divided by how many games you sell. Here's our total cost divided by the number of games. So C bar as a function of X equals 0.95x plus 6,000 all over X. That's it. That's all I have to do. It doesn't say solve anything. It doesn't say determine anything. I'm not plugging numbers in anywhere. All I'm supposed to do is write this as a function of X. And that's what this is. So there's B, and there's A. Okay, that was 98. 102A. Let's take a look at 102A. 102A says, find f of 2007 minus f of 2000 over 2007 minus 2000. Okay? All right, so f of 2007, well, I can get that from this table. When the input is 2007, the output is going to be 80. So this is 80. And what about f of 2000? F of 2000 is 35.4. 35.4 over 2007 minus 2000. Well, let's do some subtraction. 80 minus 35.4 is 44.6, and 2007 minus 2000 is 7. So I could decimalize this by dividing by 7, 6.371. But I'm also asked here to interpret the result in the context of the problem. Well, this is a slope formula. This is the change in the number of millions of tax returns filed through e-file. This is millions of tax returns on top. And on the bottom, we have years. So what is this number? Well, this number is 6.37 million e-filed tax returns per year. Or 44.6 million over the 7 years. That's how much the number of e-file tax returns changed, right? We went up by 44.6 million tax returns over that 7-year period, which on average was 6.371 million tax returns every year. Increase. This is an increase. This isn't how many people filed. This is the change in the number. So the number of tax returns e-filed went up by 6.371 million more each year, year after year. Okay, there's 102A. What about 119? 119 says, think about it. F of x equals the square root of x minus 1, and g of x equals 1 over the square root of x minus 1. Well, I remember from our Graphing Basics unit, when we started talking about the domain, we said we couldn't have a negative under a radical. So x minus 1 is greater than or equal to 0, or x is greater than or equal to 1. So my domain for f is 1 to infinity. But what if I take that radical and put it in a denominator? Remember, we also said when we started talking about domain in August that we can't have 0. Can't be 0 in the denominator. Well, square root of x minus 1 can't be 0. What would cause this to be 0? Well, if we square both sides, x can't be 1. Over here, x was okay with being 1. I could take the square root of 1 minus 1, or the square root of 0. The square root of 0 is 0. But here, because I can't have a 0 in the denominator, x can't be 1. And so my domain over here would be parentheses 1 to infinity. 1 is not included. But over here, 1 is included because this radical is not in the denominator. Now, some people might be saying, well, Mr. Kukla, the only number you can't have is 1. I remember doing these domain problems. Why are you saying only over here? Shouldn't the answer be these numbers as well, because only x can't be negative 1? Well, let's think about that for a second. Let's test a value over here like x equal to 0. What happens when you plug a 0 in here? you get square root of 0 minus 1, which is square root of negative 1. Is that a real number? Nope. Remember, we're taking this domain and we're further restricting it by putting that radical in the bottom. This domain says you're only looking from 1 and above, and here we see why. These numbers are only going to produce imaginaries. So my domain for g of x is parenthesis 1 to infinity, whereas my domain for f of x is bracket 1 to infinity. Okay, let's take a look at the last problem, problem number 122. In your own words, explain the meanings of domain and range. Well, domain is the set of numbers I can plug into a function. And range, I guess we could call these all the inputs. The range, meanwhile, is the set of all possible outputs. What are all the possible y values that I could get out of this function? You know, when I think about this function, y equals x squared plus 2, well, the lowest y value here is 2. My domain might be all real numbers. I can plug any number I want in there. But my range is bounded. My range in this problem would go from 2 to infinity. The domain would be negative infinity to positive infinity. I can plug any x value I want in there, but I can't get every y value. This is the lowest y value, and my function goes up from there. Okay, well, I hope this was helpful. I'll get this posted right away quick so that you can watch this and take a second look at last night's homework.